Hey, this is Shivani Oza here under CSE 438 Embedded System Programming course at Arizona State University. Me and my project partner Harsh Patel has made this video presentation on the first assignment of it, which is shared message queues in user and kernel space. In this assignment, basically the objective is to create shared queues in user space as well as kernel space. Basically there are two parts for it. In first part we make a library to do such, and in second part we made a module in the kernel side to create a shared queue and its functionality. Here the message bus is basically a useful middleware to support communication among various user applications, and the bus daemon is an example of it, which manages the connection between these user applications. Here in this assignment, basically we make a test program to initiate multiple threads to access shared queues and as per the following diagram. And also we have generated the shared queues to enqueue and the dequeue for the enqueue and dequeue operations, and record the queuing time. The queuing time is basically the elapsed time between the enqueue operation and the dequeue operation. For example, if one message is enqueued here and it is dequeued here, then the time difference between it can be considered as elapsed time. Here, as shown in the figure, we are creating 8 threads: the 4 sender thread, 1 bus daemon thread, and 3 receiver thread. Also, we are creating the 4 shared queue, which is first in first out, and which can be accessed by this thread. For example, this bus in queue in this bus in queue shared queue, the sender will send message, and the bus daemon can read messages from it. Here each message is represented by a unique message ID. It will also contain source and destination ID and the accumulated queuing time with it. Also the messages are generated randomly, and it will be of the maximum length of 80 characters. Here, when the message is dequeued, its queuing time is computed by the driver based on the timestamp counter and at the enqueue and the dequeue instant. Also, the total accumulating time would be the first enqueue moment and the second dequeue moment, again the here first enqueue and last enqueue. So the time between this and this instant would be considered as the elapsed time. Also, here the queue length, the default queue length can is need to be set as 10. Here the base period is defined as 1000, and the period for the bus daemon and the sender and the receiver threads are like is different according to this. For example, the 12 is for the bus daemon thread, so at every 12,000 microsecond it will read the messages from the bus input queue. Here the threads operates as follows. Periodically, each sender thread creates a random number of messages and writes them into the bus input queue. And if this enqueue operation fails, suppose when the queue is already full, then it will drop the message and proceeds it operation again. These messages are generated randomly again, and the destination is also chosen randomly. Also, the bus daemon is waked up in each 12,000 microsecond, and it will read from the bus input queue and forward it to the bus output queue here, and the to which receiver it will send would be decided by the destination ID in the message. Also, in the last, periodically each receiver thread performs the operation of reading all queued messages from its input queue. So and lastly, the thread is having also priority. According to this, the higher the priority number, it will be on the higher priority. And in this assignment, we need to send total 2000 messages by the different senders, and need to calculate how many messages are dropped, and the average queuing time, and the standard deviation of message elapsed times. For example, here we have already run the program, and the total number of messages are 2000 at the end of the program, the in which the successfully transmission of that 1052 messages and received was 1042. So the like deduction, like apart from this, would be dropped, which is 958. And again, the average message queuing time is 126 this millisecond, and each one is having different elapsed time, like this and this, and the standard deviation is again as shown. And here, as I said, we perform this thing into different parts. In part 1, we have created a library for that creation and for the reading, writing and deletion of the messages into the queues. And for the second, in the second part, we have developed a kernel module for the same operation, and it that open, write, read and release operations were there.
Hello, Harsh here. Now I will explain you the program. So in the first part of the program, what we are doing, I will explain that. So in the first part of the program, we have to make a library to implement a side queue. So exactly this is the main part of our program, and we made a library function to implement the side queue. So this is the header file in which which we define the message and the queue structure, and also they define the function that we are implementing in the serial queue sq.c library function library. So exactly in the main program, we are creating 8 threads, as Shivani told to you that we are creating 8 threads, 4 at the sender side and 3 at the receiver side, and 1 bus daemon thread. So there are 3 functions. One is the sending function, other one is the function of the bus daemon, and the third function is the receiving function. So in the main program, we are going to create a threads according to the priority. So we are setting the priority using the get schedule param and set schedule param, and before that we are creating the bus side queue using the sq create by calling the sq create. So in sq create we are allocating one queue structure. So we are allocating the size to the queue, and we are also initializing the variables of the queue, which is head, tail, and there is one extra variable to denote whether the queue is full or not. So there are main sq write function, sq read function, and the delete function to delete the queue. So in the main function, after creating a thread, the thread will there are 8 threads. One thread is for the bus daemon, this thread. Another 4 threads is for the sending function, and the 3 threads for the receiving part. So in the sending part, it will call the sender function. So sender function will send the function using the sq write. So here we are using the mutex lock to log the global variables. So in the for 2000 total messages, we are sending using the sq create that is defined in the library. So in the sq create, we are sending the pointer of the message and also the pointer of the side queue. So there are 4 side queue, one at the sender side and 3 at the receiver side. So in the sending function, we are sending the pointer of the sender side queue. So it will come here. So in the sq write, it will store the message, not the message, it will not store the message, but it will store the address of the message, and it will increase the head count. So and after that it will get written. So after it's going to get written, the transfer count is going to increase. For ensuring the periodicity, we use the clock nanoslip. So using the clock nanoslip we implemented the periodicity. So the first part, the we have to send a message from sender to the sender side busing queue. So that we have done in the sender function. So after the in bus daemon function, we have to read from the busing queue, and according to the receiver ID, we have to give a message to the output side queue. So during while in the sender function, we also send the destination ID. So according to the destination ID, it's first it will read from the input side queue, and according to the destination ID, it will going to write again into the output side queue. So in the read function, according to the message pointer and the queue, we have the pointer of the busing queue that we have sent here. We sent a busing queue pointer, so it will get that pointer, and from that pointer it will give the address of the message that is on the tail. So it will send a address from the tail, and it will increase the tail. So this side queue is a ring buffer. So it's a circulating buffer, means head and circular buffer. It's a circular buffer. So the bus daemon will do receive the function from the sender thread, and according to the destination ID, it will write to the receiver side queue. So after that, the receiver function. So receiver function will receive the message from these three side queues: bus out q1, bus out q2, bus out q3. So in the receiver function, according to the receiver ID, we will read from that bus out q1 either, or bus out q2, or bus out q3. So that will be done using the sqread command, and it will also call the library function. So after that, after getting so in the sq.c, we are also storing the timestamp counter using the rdtsc. So here we are storing the enqueuing time, and in the read function, we are storing the dequeuing time, and we are doing the minus from the enqueuing time. So we will get the total enqueuing time. So we will count that queuing time by dividing it with the CPU clocks per millisecond. As we are taking the time into milliseconds, so here it's CPU clocks per milliseconds. It's 19 something. So this is the function of the receiver function. So that's how we are able to send messages, and from that messages, some messages are getting dropped, and we are only receiving the 1042 messages. So message queuing time is 126 milliseconds. This is the average time. So you can see here that this is the send message at with 1998 ID. So you can compare this with this. So we are getting the message that we have sent to the busing queue, that we are getting from either bus out q1, either bus out q2, or either bus out q3. So that is random. So in the next part of the assignment, the test program is almost same, but instead of we are calling the library function, here we are doing the system call. So for system calls, we will include the module. So for module, this is the driver for the side queue. So in this there are mainly four file operation that we have implemented. So in the initialization part we will do the same thing as that we have done in the sq.h, and also the things that are needed for to create our own structure. So we have created our own device structure. So we have used semaphore here, same as we have used in the library mutex log. So here in the driver we are doing the my open, my close, my write, and the my read. The function of the my write and the my read is same as the sq write and sq read that was there in the library part. So here also, but here in the library part we are storing the messages, not only getting the pointer of the message, we are storing whole message. And when the bus daemon or receiver thread will read the message, we are again copying whole message to uh, the thread which called my read. So we are storing the message, so we also allocated the structure of for that to store the messages, and we also assign the space for that. So in the delete part we will free that messages, that space. So here we are freeing that space. So here also that's the same thing that we have done in the part 1 main test program thread. We are doing the same thing, but instead of the calling the library function, we are opening the our own serial queue driver, and that side queue driver, and from that we are writing to the side queue. And after that in the bus daemon function we will read the message, and according to the destination id we will send we will write to the receiver side queue. So that's all. So after in the bus daemon task is done, and after that the receiver function task is to collect the messages from the receiver side queue. So it will collect the message from the bus out q1 or bus out q2 or bus out q3. So that's all. Thank you for watching the video.